As we move on to 11-6, we're going to talk about this concept called inverse variation. Now, inverse variation is probably exactly what it sounds like. Inverse to you probably means opposite, and variation means that that things are connected together, like one varies with another. So let's go ahead and put that together. Inverse variation happens when one item or one variable goes up and the other variable goes down, or vice versa. So that is inverse variation. You're going to learn today this equation called y equals k over x, because if you have y equals k divided by x, as y would go up, x would go down. And as x would go up, y would go down. So our object today is to write and graph these things, and then we're going to compare what it would mean to be direct versus indirect. So we're going to go ahead and fill in our blanks. As one goes up, the other one's going to go down today. This is a really nice problem. Let's try to remember to do it when we get in class together. And let's go down to problem 1, writing an equation given a point. So anytime you see this sentence, suppose y varies inversely with x, that little phrase automatically gives you this equation. Y equals k over x. And that's what it means to vary inversely. So now what they're going to do is they're going to give you values to plug in. When we plug these in and we solve, we're also going to find what k is. And k is called the constant of variation. So let's go ahead and say 8 equals k over 3. I plugged 8 in for y and 3 in for x. Multiply each side by 3, and you should get that k is 24. This is called the constant of variation. Alright, now what we're going to do is we're going to figure out the last part, and it says what is an equation for the inverse variation? It's y equals the constant of variation we got, 24, over x. So you should notice our goal in this problem was pretty much just to find k and make an equation. Our goal in this problem was to find k, our constant of variation, and make our equation. Let's try that one more time. In got it number 1, it says the same thing. Suppose that y varies inversely with x. Y is 9 and x is 6. That would be a point. So we do y equals k over x, and then 9 equals k over 6. Oops, sorry, there you go. Multiply each side by 6. 54 equals k. Now we're going to just plug that in and get the equation for the inverse of variation like it wanted. And all we do is we plug in k. And that's it. That's how you make your equations. So let's keep moving on and see how we do. We're going to do a word problem now. And it says, let's see. The weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. How far away from the fulcrum should the person sit to balance the lever? Alright, so maybe I would hope this is at a circus. Yeah, we'll say it's a circus. Now, have you guys ever been on like a seesaw where, you know, if you're the heavier person, you want to sit somewhere. If you're the lighter person, you want to sit somewhere on the seesaw. And that way you balance. Have you ever done something like that? Well, that middle spot, this area where it teeter-totters, that's called the fulcrum. Okay, so we have a 160-pound man, and we have this 1,000-pound elephant, and we need to figure out, in order for this to balance, we want to know if we put the elephant 7 feet away, where his foot is, if that's where all of his weight is, 1,000 pounds, we want to know where should we put the man so that they're going to balance one with another. You never thought we'd do a circus problem, did ya? Alright, now we're going to go ahead and make our equation. It says the weight needed to balance the lever varies inversely with the distance away from the fulcrum. So we're going to make this general equation right here of W equals K over D. Now we're going to plug in the numbers that are given to us in the chart, okay? We know that we have 1,000 for the weight of the elephant, and that's going to equal K over, we know the distance of the elephant away from the fulcrum is 7. Multiply both sides by 7, and we'll be able to figure out what K is right away. So we get 7,000 equals K. That's the constant of variation, so we can make our general formula W equals 7,000 over D. So now we're going to plug in to figure out the actual question, and it says, how far away from the fulcrum should the person sit or stand to balance the lever? So we're going to go over here and we're going to take our equation that we made and we're going to plug in what value we have. Now we have 160, which is the person's weight. So we're going to do 160 equals 7,000 over X. That's the distance. That's what they're asking about. How far away should the person, that's a D, how far away should the person stand? So now you guys, we don't like denominators, right? So I'm going to multiply both sides by D, so those cancel out. And I get D times 160 over here. So I'm just going to write 160D equals 7,000. Now how do we divide by D? Divide by 160. We got an extra step in this one. So we're going to get our calculators and do 7,000 divided by 160. And that man should stand 43.75 feet away. So we'll write D equals 43.75 feet, that was messy, away from the fulcrum. There you go. Alright, let's keep moving on to the second part. It says, now we have a 120-pound weight that is placed 5 feet from the fulcrum. How far from the fulcrum should an 80-pound weight be put in order to balance? So if you need a picture, if you're like me and you're a visual learner, here's your fulcrum. And we can say that right here, there is a 120-pound weight. And that is 5 feet away. And now they're telling us, how far away should we place an 80-pound weight? So we're going to make our equation based off of this information over here. We know that weight varies inversely with distance. That's what we learned in the problem above. And we'll plug in, that's 120 for our weight, equals our constant of variation over 5 feet. Multiply 120 times 5. 600 is the constant of variation. Now what we need to do is write our general equation, not y, we're dealing with W here. W equals 600 over D. And you notice in this particular problem that our constant of variation is smaller. So now they're asking us to plug in 80 for the weight. So we do 80 equals the 600 that we had over D. Multiply both sides by D to clear your fractions and divide by 8. So 600 divided by 8 is 75 feet away from the fulcrum. Okay? And this should say 80, not 8. 80. Divide by 80 and we get 7.5. I apologize. Can you make that 80D and divide by 80? I only divided by 8. Okay? I was to 0. So make it 7.5 feet away from the fulcrum. Now you get the fun task of learning how to graph inverse variations. Okay? Graphing. Now today I'm going to give you a hint, and tomorrow we're going to talk about them a little more in depth. And today, notice it's just y, x, and your constant of variation. what we're going to do more in 11-7. In 11-7, we're going to move it to the left, to the right, up, and down. But today, what you're going to have to understand is, you see how x is in the denominator? I'm hoping to you that that means you understand x cannot be 0. Now, something else to note is that if we rearranged our equation, you should also note that y cannot equal 0. There's no value for x and y that you could ever plug in so that those could equal 0. Now, you might be wondering, what do you mean, Mrs. L, that you can rearrange your equation? I'm hoping that you guys would be able to tell me that if y equals 8 over x, you could switch x and y, okay, and you could say x equals 8 over y, all right, and that would be like multiplying by x and dividing by y. So in both cases, y and x are never allowed to be 0. All right, but let's go back to our original, where we have y equals 8 over x. My table of values, here's what we're going to do. Since x is not allowed to be 0, we're going to make 0 the middle spot, okay? So 0 is what it's not allowed to be. So I'm going to pick values like, now let's think, we got 8, right? Can we think of some factors of 8? Now I'm doing factors of 8 so it divides out really nice, okay? That way I'm not doing like 8 divided by 5 or 8 divided by 3. All right, let's think of some factors of 8. For example, 1, 2, 4, and 8. Those would be really good values for us to pick for x. And on the flip side, -1, -2, -4, -8. Those would also be really good values for us to pick. They all go into 8. So when we plug them in, we're simply going to do 8 divided by, and let's start way up here. You ready? 8 divided by 8 is 1. So that y value would be 1. 8 divided by 4 is 2. So that y value would be 2. 8 divided by 2 is 4. So that y value would be 4. 8 divided by 1 is 8. So this y value would be 8. And then when you do the negatives, it's just going to be exactly opposite of what you just got. And I think you probably know that. Like 8 divided by -4 is -2, so on and so forth. So now what we're going to do is we're going to plot those points, okay? Let's go over 1 up 8, 1, 2. Over 2 up 4. Over 4 up 2. And over 8 up 1. Notice how like these dots are beginning to form kind of a J shape. They almost look exponential to you. Now let's connect and watch what happens. Remember how I told you x and y can't be 0? They're going to approach the axes, but they're never going to touch the axes, okay? They're never going to cross the axes. Therefore, your x and y axis are what we call the asymptotes. Let's go ahead and plot the negative side. -1 down 8. -2 down 4. -4 down 2. And -8 down 1. Can you see how it's making this really funny shape on this side as well? This is how inverse variations always graph. They're not a straight line at all, are they? They're two different curves that never touch the axes. So graph them, and let's try one more down below. Now the reason the one down below is a little bit different, take a look at got it 3. Now we're going to graph a negative inverse. And you guys are going to see how a negative inverse looks different than a regular inverse. Okay, now just like before, your middle point is going to be 0. We're not going to plug in 0 because x and y can't be 0. So that's going to give us kind of the dividing line here. Okay, and just like before, we're going to think of factors of 8. Okay, just like before, we're going to think of factors of 8. That way we can divide nicely. Alright, you ready? So we're going to pick the exact same values. 1, 2, 4, and 8. And again, we'll pick -1, -2, -4, and -8. You could pick like -16. You're just going to get like 0.5. Okay, now let's plug those in. -8 divided by 1 is -8. So put that here on your y value. -8 divided by 2 is -4. Put that here on your y value. -8 divided by 4 is -2. That's your next y value. And -8 divided by 8, again, I'm just plugging it into my equation, is -1. Now this side over here, the only thing that's going to be different are the signs are going to be exactly opposite. Now plot these points and we're going to compare how a positive inverse graph compares to a negative inverse graph. So we'll go +1 but down 8 this time. +2 but down 4. +4 down 2. And +8 down 1. Pause the video if you haven't caught up to me yet. We're going to graph these and we're going to notice that this, once it approaches the axes, both axes, but it will never touch either one. Do the next thing and go left 8 up 1. Left 4 up 2. Left 2 up 4. And left 1 up 8. Again, you'll notice the exact same thing happening. We approach the axes, but we never cross or touch them because both the axes are asymptotes because they're both restrictions. All right, I'm going to finish the rest of the notes on another video.